Hi everyone, Dennis Foley from Acoustic Fields. Today we're going to talk about cardboard boxes. Named to kind of get you thinking about the construction of your room and how every variable in your room is important, okay? Noise transmission is, I don't know if you have a chemistry background, but there's osmosis and diffusion. You know, osmosis is going from I think a region of higher concentration to a region of lower concentration, density in fluids maybe, air quality and things like that. And that's really what we're doing here in a room. We're going from an area of high concentration, which is like noise, okay? And we're going into an area of very low concentration, the room. But once you get in the room, the noise can become quite bothersome because even though the walls in our room help with some of the frequencies and amplitude of noise, in critical listening environments, it doesn't help that much because our criteria is much higher. Our noise floors are much lower, and the requirements to get to those are much greater. So we got to be very concerned with what we're doing. And when we're dealing with noise, we're going from air energy, noise that's being transmitted through the air, striking a solid surface in our walls, and then entering our room. So it's vibrational acoustics that we have to manage. That's the science that we use. The room must be constructed in a way to minimize the vibrational signature. Remember that in acoustics, it's step by step, right? So if we start with a good construction in our room, we have a lot better chance of lowering the noise floor as we go up the steps towards what's the ultimate step, resolution, right? That's what we're up to here. So if we're going to be a room frame, we must have a good bones. I was a real estate developer for many, many years and did a few rehab projects. And the term that was always tossed around was bones. Does the building have good bones? Is the structure of the building solid enough to do two things? One, warrant the improvements, and two, justify the cost over long-term periods? Or do we have to tear it all down and start all over again, which is very expensive? So we want to take what's there and improve upon it to save costs, obviously. But we got to have good bones. I see a lot of rooms today with 2x4 construction. Have you ever closed a door, an exterior door in a 2x4 wall? You close it hard, the whole wall shakes. Now, that's a big impact. And speaking of impact, when we test our rooms, we use rubber hammers. It's funny, because you close the door and you get a big impact. Well, you hit surface areas with a rubber hammer, you get a similar kind of impact. You can get a sensibility and you can measure that impact in a vibrational signature. But in a 2x4 wall, it's almost like a cardboard box. It's got no rigidity at all, no strength. Even if you put sleepers between the studs, which are the horizontal pieces, to tie it all together, because you've got horizontal, vertical domains when it comes to vibration. What is there, static and dynamic? So you have to be very, very careful here. So we don't ever use 2x4 studs to frame out any room. 2x8's the minimum. And that's mainly because of space requirements. But with a 2x8, you can get a good structure to start with. And from there, we can make it stronger and add to it and go from there. Now, if we do our CAW system, that's a 2x12. Well, the big difference between a standard 2x8 and a 2x12 is about 3 inches more in depth. Well, that's another 2 octaves in treatment that we can go lower. So that's why our 2x12s are required for the CAW if you want to go down to 30 cycles. If you don't, 40's fine. Well, you can get away with 2x10s, but it's all depending on your usage and what your sonic goals are, right? Carbon technology increases vibration management because when we install the carbon between the studs, if we have a stud and we have a carbon filter that takes up a big percentage of the stud with sleepers top and bottom, you're going to get a nice, because how do you attach the filter? Well, you screw through the studs into the filter, and it's designed to do that. Pre-drill the holes, of course, because going through 1.5 inch studs is not an easy task in one push, right? So if it's pre-drilled, it's a lot easier. Don't have to pre-drill the filter, but you do have to pre-drill the stud. Okay? So we're going to increase vibration management there with more rigidity. We're going to lower the pressure amplitude in the room. So that means there's less pressure pushing against the structure and the walls. And then we're going to minimize the transfer of vibration. Everything has to be designed to minimize the problems of the thing before it. Like I say, it's a step-by-step process. So, windows and doors, the weakest link. I think there was a show on TV. You are the weakest link. Doors and windows are the weakest link in the structure. Why? Because they're not the same density as the wall. And sound is like water. It'll look for that weakest part and drip through it. Noise is like water. So it'll find that weak link and drip through it. Windows are a weak link. Doors are a weak link. And if you have a structure that has a 12 to 15 pound per square foot density, and you have a door that's 3, where's the noise going to go? It's going to go to the 3, not the walls, see? So when we build doors, we build them out of the same structure as the walls, so the density stays the same. We've had doors 12 inches thick and big handles, and you can see in our projects, we've done it many, many, many times. So I always tell people when they're designing a room, we're really building a boat. It has to do 2 things. It has to be strong, because it has to handle the force from the waves of water and the waves of low pressure energy, right? Waves and rays. And it can't leak. Can't leak at all. A 1/4 inch hole in a wall that's designed to stop noise is a nightmare. It can defeat the whole performance of the whole wall. So you have to be careful. It has to be strong and it can't leak. So we use a lot of spray seals and stuff to make sure that all joints are sealed, especially with the CAW, because it's a pressure-based technology, and we want to make sure that it's all sealed so it can act against and with, at the same time, the pressure. So be very careful when you're building your room. No cardboard boxes, no 2x4s, no 2x6s. Stay away from all that stuff. You put pressure in that, the thing's going to move. And if it moves, we know movement produces noise. Cardboard boxes. Hope this helps. Thank you. Thank you for watching this video, and if you liked it, please give us a thumbs up. We also have a newsletter that you can subscribe to, so please do that because we offer special price discounts to only those on our newsletter. And then don't forget about our forum. We have started a forum on our own website where people ask questions, and I usually get a chance every couple of days to look at it. There's an interchange between people on the forum, and we'll give you real answers on a regular basis, so that'll help you. Thank you.